Lesson 43, the chi-square test for independence. Example 3. The National Highway Traffic Safety Administration, or NHTSA, sponsored a study investigating seatbelt usage. As part of the study, a random sample of vehicles were selected on roadway sites nationwide. Information regarding the driver's age and whether they were wearing their seatbelt or not was collected. The results are shown in the following contingency table. This contingency table has 2 rows corresponding to the categories of drivers which either were wearing their seatbelt or not wearing their seatbelt, and 3 columns corresponding to the 3 categories of driver age, the 18 to 24-year-olds, 25 to 34-year-olds, and 35 to 64-year-olds. Question: is a driver's age independent of their seatbelt usage? Then, based on this result, what should the NHTSA report about the association between a driver's age and their seatbelt usage? We'll address the first question first. Is a driver's age independent of their seatbelt usage? Since the issue under investigation here involves determining whether these events are independent or not, the chi-square test for independence is used to determine whether the 2 events are independent of one another. Then, after we conduct the chi-square test for independence, we could address the second question, which states, based on this result, what should the NHTSA report about the association between a driver's age and their seatbelt usage? So, referring to our guide, which shows us the steps to follow in the chi-square test for independence, we start by stating the hypotheses, HO and H1. In the chi-square test for independence, HO is always stated that the events are independent of one another. And H1 is always stated that the events are not independent of one another. After stating the hypotheses, we then identify alpha, the level of significance. Here we use the customary alpha of 0.05. Next, we can use the chi-square test command on the TI-84 calculator to calculate the p-value required to reach the decision. But first, we need to enter the observed frequency data into an R/C matrix in the TI-84 calculator. So, referring to the contingency table, which displays the observed frequencies, we can then enter the results in a matrix by pressing Second, Matrix, arrow over to Edit, press Enter to select. This contingency table has 2 rows and 3 columns. So we enter the 2 by 3 matrix. Then we enter the observed frequencies across the first row, 52, 85, 121. And then we enter the observed frequencies on the bottom row, 19, 20, 18. Now we could select the chi-square test command by pressing Stat, arrow over to Tests, and then arrow up the cursor next to chi-square test. Press Enter. We entered the observed frequencies in matrix A. The calculator will store the expected frequencies in matrix B, and then we press Enter under Calculate. So here we see the results of the chi-square test for independence. Specifically, we need the p-value. So rounding the p-value to 3 places after the decimal, we see that the p-value is approximately 0.046. So therefore, since the p-value of 0.046 is 0.05 or less, the decision is to reject HO. And when we reject HO, we have evidence indicating that HO is not valid. Thus, the alternative, H1, is the one that is considered to be valid. So in this case, the evidence supports the idea that the events are not independent. So, based on the results of our chi-square test for independence, we could reach the following conclusion. Therefore, a driver's age is not independent of their seatbelt usage. Now, the conclusion that they're not independent indicates that there is an association between these variables. To see the nature of the association, we need to look at the observed frequencies in the contingency table. Notice that of the drivers that were not wearing their seatbelt, the observed frequency distribution across the age of the drivers were essentially the same. Whereas, of the drivers who were wearing their seatbelt, the observed frequency distribution across driver age increases. That is, proportionally speaking, we could say that the proportion of the younger drivers, 18 to 24-year-olds, that were wearing their seatbelt was lower, and the proportion of older drivers, aged 35 to 64, that were wearing their seatbelt is higher. So, based on this result, the NHTSA should report that a higher percentage of seatbelt usage is associated with older drivers, aged 35 to 64 years, and a lower percentage of seatbelt usage is associated with younger drivers, aged 18 to 24 years.